Alright, here we are in kitchen. The technicians have removed the filters. They're just getting ready to set up their containment drape. And we have one of the guys spreading out the plastic now for this back hood here, which is a prep hood. And they'll be putting drapes up in both these hoods. They also have a vat going on to soak their filters. Alright, here's what we're going to use for a vat. We're going to use a deep sink. We also have a portable dip tank in the back of the truck we could use if we didn't have a nice deep sink, but we're going to use this deep sink, and we've checked it out. It's got a proper floor drain, and all the wastewater, when we get ready to dispose of it, will be going down the floor drain to the grease trap. If we look out the back door of this facility, we see we've got a beautiful, tranquil little river that runs down through here. This is called the Orange River. This goes on down about 3 or 4 miles to another river further on down called the Caloosahatchee River. But we don't want any of our wastewater running into this this nice ecological environment here. Now I just observed the tech take some grease cups and throw them in his drape here. And he poked a hole right in the bottom of his drape, and this is keeping the drape tight so that any rinse water will flow to the lowest point, which is the cups, and then into this barrel. Just a little note on what that dip solution did to a greasy filter. Now there goes the dirty end down. Alright, here comes our dirty, greasy water out of the overhead ducts. And it comes down in the drape and into our bucket. Okay, what we've done, we've opened up the roof drain here, and I asked him to put some Dawn soap in a bucket, and he's going to pour it down the roof drain. I'm going to go down below and see if I can see any soapy water come out into some areas I suspect might be where the roof drains. If I don't find any soapy water, I'm going to presume that this roof drain is connected to the sanitary system that's going down the sanitary system. So anyways, I'm going to go downstairs and we're going to go look for some soapy water. Now we've determined that the roof drain comes into this wall somewhere, and I look and there's a drain right down in there, and there's a couple more drains back down in here. Alright, there's a drain there as well, and if we look out over here, right in here is the pad where the sanitary sewers are. There's the sewer covers for the sanitary sewers. Alright, I've come out behind this building on the other side as well, and I've walked all around the perimeter of the building to look and see if there's any drain spouts coming out with that soapy water. There is no soapy discharge anywhere around this building. Okay, I'm out on the back deck of this facility, and I'm overlooking the river. I look down the river to make sure there's no soap water coming into the river, and I am reasonably confident that we have contained our runoff from the roof, that it is going into the sanitary system of this facility and not out into this ecosystem. Alright, we're in a kitchen here where we just saw our man prepare a sink for dipping filters. So we have a small vat of alkali here that we've been dipping filters in. Now, back in 1977, the federal government, more namely our Congress, adapted a Federal Clean Water Act, basically with a lot of restrictions as to what we can discharge into our wetlands and environment safely without violating this Federal Clean Water Act. Now, they established another organization to police it called the Environmental Protection Agency. Now, furthermore, the Environmental Protection Agency lets different states, counties, municipalities have their own guidelines set up as long as they fall within the Federal Clean Water Act. So you can be dealing with the EPA, you can be dealing with a local municipality's drainage and sanitation department, you can be dealing with the federal fish and wildlife people. There's a lot of people that enforce this Federal Clean Water Act. Now, within the Federal Clean Water Act, they have a guideline about dumping alkalis and acids into the environment. Now, even though we're not dumping into the environment, we're dumping into the sanitary line, even most of your local municipalities will only accept within the federal guideline. And the federal guideline for wastewater pH is no higher than 12 on the alkali scale and no lower than 5.5 on the acidity scale. So how do we determine our alkalinity of our product before we discharge? We have basically a couple of different methods. I like my guys to use litmus paper. It's easy to work with. Our guys don't have to be entrusted with expensive meter equipment. Speaking of meters, that's another way we test. Now, I personally keep a meter in my desk drawer because I like to check and make sure things are getting taken care of right to the T. And what we have here is a pH meter that's got a basic on-off switch on top here that we can turn it off and on. And it's got a couple of adjustment screws up here for adjusting your pH. Now, what we need is what's called a buffer solution for calibrating our meter. This is a pH 7 buffer solution. This can be purchased again from Granger's or most any chemical supply house. Now, what I like to do is put my buffer solution into a small medicine bottle. It makes it convenient. I'm not going to contaminate my main supply. I pour a little buffer solution in the medicine bottle. I turn my meter on. I set my meter in the buffer solution, and I want this meter to settle down at close to 7.00. Now, right now, my meter is reading 7.00 because we just used a razor blade here to calibrate the little set screw on it. We got it calibrated at 7.00. Right now, it's bouncing between 6.99 and 7.00. That's very close, so that we can go ahead and test our solution. All right, now, at this point, I'm going to let my technician take over here and show you how we are going to neutralize this vat and neutralize our wastewater barrels where we collected our wastewater from our hood washing. As you see, we've got about a 40-gallon barrel here, and we've probably got about 25-30 gallons of wastewater here. All right, Scotty's going to take his litmus paper and he's going to drop it in his vat first. Now, if we look at that bottom color strip, it is bright pink. That is indicating off the scale that I got on my bottle, it's higher than 8.4. I'm going to guess it's probably close to 13, 14. It's right up there on pH. Very high alkalinity. All right, we want it to come down to where it's about a 7 to 8 scale, which on my little bottle there looks like a bright orange. All right, so anyways, what we're going to do now is we're going to use something to neutralize our solution. And what we have here is a product that is a vat neutralizer, and we can see where we can get this vat neutralizer. All right, and if we take a look at the side of the jug, we can see that it has a hazardous label on here. It says it's corrosive, and it contains sulfuric acid. All right, and sulfuric acid is an excellent neutralizer for alkali. I've used it for many, many years. All right, what he's going to do now, we have a full container here of this neutralizer. It's kind of heavy, so we're going to pour a little of it into a bucket. Easier to work with. Now you always want to slowly introduce your neutralizer, in this case sulfuric acid, to your alkali. And we're just going to add a couple of cups in here, stir it around and see what happens. Okay, hold it, Scotty. Let's stir it up and see what happens for our pH. Yeah. And it's important that you mix it good. All right, he just added a couple of more cups of this vat neutralizer to our vat, and we're going to test it here. On the initial test with the meter, it came out 12.46, and we're going to see how it comes out here now. And we can see the actual color of our solution here turning to a lighter color. We know something's going on here. Now what we did when we just added that second shot of acid, he actually went too much, and we used the meter and it came out to be, what's it saying over there, 4.35. It went in a shot from 12 down to 4, so he went too much. It takes a little practice to get used to working with this to see how much you're going to need. Just swishing it around there until it settles down. All right, what are we saying on the meter here?
Saying 6.1.
6.1. All right. We are within our guidelines right now. I said it's got to be between 5 and 12. All right. We could add a little more alkali here if we really want to mess around, but for the heck of it, let's take a litmus paper and let's see how the litmus tells us. Okay. Okay. All right, that's it. Now there's our it's right at the light orange. It's between 6 and 7, and our meter was saying 6.22. So that shows you how your litmus works for testing your alkalinity. The meter says 6.27, and that is according to litmus, it's showing it's between 6 and 7, a little bit higher. But it's like I said, go for 8, and you're safe. All right, we just pulled the plug on the sink, and we're draining our neutralized solution. Okay, what we're going to do now is we're going to test our solution that came out of the hoods, and we've got that bright purple color again, almost the same thing with what the vat was. That's off the scale. It's up there again, probably 12 or 13. And
12.21.
12.21. All right. So we want to get it down to 8. We're going to add our vat neutralizer to it. All right. Okay, we got it mixed up good. Now we're going to test it with our litmus paper and see what our litmus says. And it looks to me like he put too much acid in. He's way down on the yellow chart. Let's just text it with our meter, and what does the meter say? Three. Well, we got to get up above 5.5. How are we going to do that? We're going to put a little more of our caustic in there and bring it up. Okay, we just added a little more alkali, and we're going to see what we have here. What are we at?
Looks like it's in between 6 and 7 again. The little orange. It's not an 8.
All right. I guess it's between 6 and 7 as well. Let's see what the meter says.
It says 6.2.
6.2. Good job. We can dump. All right, there goes all of our treated wastewater going down the sanitary line to the grease trap. And that's how we properly dispose of wastewater. Now, in this corner of our shop, we have pretty much all of our chemicals contained in a certain area where we're going to work on them. These barrels over here are pre-mixed degreaser that we mix up for our guys to fill their jugs and go to work with. If there were a fill in their jug, or if one of the hoses were starting to leak, it's going to run into this self-contained moat area where they can come and bring their shop vac in, suck it up, clean it up, and keep it clean. Over here is a wash sink where our route man cleans his filters for filter exchange. All right, the water is pumped from this sink out the pipe over and down into this tank here. This is a holding tank where we treat our wastewater before it is discharged out of the tank down into a sump over here, where it is pumped back across the facility into the back room, which we're going to go back there in a minute, where the grease trap is. All right. Now, you'll see why we need to pump our water into a holding tank when I open this lid. In this tank is dirty, greasy, smelly water. We've got grease and oil sitting on top of the tank, and we've got water that's got a high pH from the rinsing solution on our filter operation. All right. Now, to neutralize the tank, what we have to do, first of all, is get all the grease and the oil off the top of this. I don't want it going into my grease trap. Even though I got the trap in there, that's my safety net. I want to get most of the grease out of here before it goes into the trap. It only takes a couple minutes. All we do is take and just run it over into a pail here and get most of this grease that's floating right on the top off. Put it into a bucket here. Oh, this is so lovely. Man, I've managed to get the majority of the grease and the oil off the top of the tank. Now I got a nice full pail of it. Now, what do we do with this? All right, in our facility, we are in the grease trap cleaning business, so we have tanks out behind our building that we store our grease waste for a rendering company to come suck up the tanks when the tanks are full. So right now I'm going to go dump this into our rendering tanks out back. So follow me. All right, now this is our rendering tank. Now if the crews are working on a job and they have a pail full of grease, they aren't going to pour it down the sinks because it's going to plug up the drains, and they aren't going to pour it in the dumpster. They're going to go pour it into rendering barrels in the restaurant or the facility. All these commercial kitchens have rendering barrels that you can pour grease. The rendering companies don't like it when you pour your wastewater in there, but the grease and sludge, that's fine. All right. So there goes our grease into the rendering tank. Now we're going to go in and finish neutralizing our wastewater. Now we're about ready to start our neutralization process. This has a high pH. pH scale is how we measure acidity and alkalinity. The lower the number, the more acid it is. The higher the number, the more alkali it is. Neutral is 7.0. Now, what we do to test this is use a meter. Now, I've learned the hard way that buying cheap meters doesn't pay because they aren't very accurate. you're better off buying, I wouldn't say an expensive meter, but not necessarily a cheap $30 meter. A meter like this runs about $120. My probe has been sitting in a buffer solution of 7.0, and right now it's reading 7.03. It's calibrated, it's ready to go. Now, we also are going to need some acid to bring the pH down in this tank. Now, personally, what we want to do first of all is determine what the pH is in our wastewater before we start. So what I'm going to do, I'm going to stick this probe down in here and stir it around for a few minutes and see what kind of a pH we got. If you see this thing, it's going 8.4, 8.5, it's climbing right on up there, okay? I'd guess that this tank is probably going to end up with a pH somewhere around 11 or 12. They usually are up there. I'm up to 9 already. But when I see what the pH is, it's going to give me an idea how much acid I want to put in here. What I'm doing now is I'm putting cold water into a pail here. What I'm going to end up doing is pouring acid into the pail to dilute it down a little bit before I actually pour it into the alkali solution. Sometimes you can pour directly into the alkali solution, but it's dangerous. It's going to react and it might spatter up on you, so you're better off diluting it down a little bit. Always add your acid and your chemicals to the solution that you're going to work with. Never add the solution to raw acid. It can have a violent reaction and you can have problems. All right, so I'm going to take this. I'm going to take some of my acid here and pour it in. All right, now turn it on. All right, I'm about ready to mix my acid. I might also make a point that you always want to have an eye wash station available when you're working with chemicals. Most of your safety equipment suppliers have portable eye wash bottles. You want to have something available just in case someone does get a splash in your eyes. All right, notice I am wearing my safety glasses, my rubber gloves. All right, what we're going to do is pour some of this acid in the water, add it slowly, because what it's going to do is start steaming here and actually get warm. I'm going to introduce it to my tank. Again, I'm going to just pour it in slowly. Okay. I want to stir this up real good. Okay, now I'm going to do a pH check on it. I want to get this pH between 10.5 and 5.5, which is our guidelines here in this area. Everyone is going to have to check their own facilities to find out what their proper guidelines are. Now, I've added too much acid. I'm already down to 2.9. All right, I got to be at 5.5. Now, what happens if I got too much acid in there? I got to put a little alkali in there to bring it back up. All right, my tank right now is saying 7.13 right here at the top. So this is where I want to be to let the tank go. All right, so what I'm going to do now, I'm going to open up the drain on my tank. I'm going to let this thing go into the sump. There it goes. Now this sump is going to kick on here in a moment, and it's going to pump up the pipe into the back room where we have a grease trap. All right?
It's on now.
All right, our pump is pumping the tank as it drains, and it's pumping over into the back room where our grease trap is. And back here, we have a grease trap in line right here, and we have a continually monitoring pH device here that's telling me that the solution going through the grease trap right now is 7.75. All right, here are 3 of our service trucks at this facility. If you look way in the back of this truck, we have a portable dip tank. All of our trucks have portable dip tanks in the back of the truck. This is the safe way to clean filters, clean parts, and be able to neutralize your wastewater before you discharge into the customer sanitary system. This truck, the lid's down, but it's got a dip tank in it as well. Anyways, all of our trucks have dip tanks. And this really helps us control our wastewater and see that the water is properly treated before it goes down the drain. I can't urge you enough to check with your local municipalities to see what their pH limits are. But it's up to each local municipality as to what the proper pH is. And like I say, be sure you're flushing through a grease interceptor so no oil and grease are getting down the line as well. All right, this is the facility that the crew's going to be cleaning the hood exhaust. And as you see, we're right on the water here. So it's very, very important not to let any wastewater come off of this roof and run down to where it's going to be able to go in the water or come into this parking lot. So we're going to show you how we control our wastewater. Okay, the guys are going to be working up on a metal roof, so Robin's getting his safety gear on. Alright, we want to determine where our wastewater is going to run, and I see a drain from one of the slop sinks up in the kitchen hooked up there, and it comes under the facility, and we can see all the drains underneath this facility, and they're all leading over to a drain that goes down to the ground over here. Now if I go out front of the building, we're going to see something. Okay, here I am out front of the building, and what we have are two sanitary covers right here. And this is for the grease trap. What they have here is an underground trap that's probably 1,000-gallon capacity, and all of our wastewater we want to eventually get to this grease trap before it goes into the sanitary sewer system. What men are doing now, they're going to install a plastic drape under the roof edge, so when they wash the fan, all the slop water is going to run into the drape and down into a catch down below. We are on a metal roof, and it will become very dangerous here shortly. But here's what we've got to work with right here. We're in a little bay off of Fort Myers Beach, but this is the ecosystem we want to protect. Alright, the guys have a trash can set up out here, and they got the drape falling down into the trash can. We can see we got the fan tipped. Right now they're down in the kitchen installing the drape. So this is where all of the slop water will run. They also put some plastic down in the stones down below in case anything runs down there. They can pull the plastic up when they're all done. Right, this is a dip tank that we use down in Florida. This is a plastic dip tank that can be purchased at Granger's. I don't know about the price of them now. The last I knew they were around $280. They're on wheels. They come in very handy. But this is what we use to dip our filters in and wash them. And when they're done washing them, they can just pour the slop water right into the grease trap down here. Alright, this is Prince, and he just pried the grease trap cover loose so that he can pour his slop down there when he's all ready to go. Alright, the men are setting up for a job here. This is how we control our wastewater down below. We install a plastic curtain in the hood, and what he does, he cuts the plastic so it extends at least 2 foot about longer than the hood on each side, and then he takes and pushes the plastic up in the crack in the back there, and if he needs to, he'll use cardboard and put some shims under there to keep the plastic from falling down out of there. We also use a lot of clips. Over here is some of the clips that they use to hold these things up in there. Clips, duct tape, cardboard, anything you can use to get it up in there and keep it up there so that it stays. And we had a floor drain down here, and he elected not to use it because it's really gross. He didn't want to go in there and clean the floor drain out, so he's just going to put a pail on the floor and catch his wastewater. But a lot of times it's easier just to go right into the floor drain. That way you don't have to be emptying and watching your buckets.
Equipment's all covered and protected from water.
Yeah. And we wanted to make a point that he took an extra piece of plastic and threw it over all the equipment, so in case anything does leak past the drape, it's not going to run in the friolators or on the stove or into any equipment. We use a lot of plastic in our operation. What we have here is a bucket down here, actually a jug, that we put a pre-mixed alkali solution, and it's downstream injection. It's going to be sucked up that plastic hose there, and it comes up into the injector, which is right there, and it sucks the degreaser into the down line. Now, we're going to be diluting that strong alkali with a flow of water, and we've tested this before. Our chemical coming out of the tip when we're applying it has a pH of about 12.5, a little bit high if we were to dump it straight, but by the time it hits the grease trap and goes through the grease trap, it's almost neutral. So anyways, they're getting ready to start washing up on the roof right now. Starting to wash the roof now. It's going to get very slippery up there, so he's tying himself on so that if he does slip, he isn't going to come off the roof. Right now he is applying our degreaser onto the fan. And you can see it's starting to run out of the fan now. Pretty soon it'll be running into the drape and down into our bucket here. It's running in there right now. So far they've probably run about I don't know, maybe 10 gallons or so in there, and it's there hasn't been a drop to hit the pavement yet. That's the way it's supposed to be. Starting to get some grease coming out of there now. Applying the chemicals on the fan up here. It takes about 10 minutes to get this thing pretty much soaked up with down the stack into the kitchen, where it's all being collected by that drape down in the kitchen. Okay, we can see the wastewater coming down out of the hood here, running down the drape, and he's got a big garbage can set up here that the stuff's running into the garbage can. And right now he's still applying chemicals, so you know, we're not seeing a whole lot of grease here. When he uses our pressure tip, you'll be seeing the grease coming off. Alright, we use Nowack high pressure nozzle for our final rinse, and does a really good job getting right down to bare metal. There won't be any grease in this hood at all, or this can at all. Now this wasn't a real bad system as you saw, but it had stuff in it. And there it comes. It's really running out of there now. Going down to our drape. Now all this is he's using right now is just clear water. So it's diluting that alkali that we've applied. There's a lot of them chunks of grease went on the roof, so you got to get them washed off. Otherwise, the hot sun down here will melt them, and we'll just have runny streaks of oil down the roof. So he's cleaning the roof all off. Now, we did get a little water. See, it's hitting the pavement right now. So we're going to have to clean that up when we're done. But it sure beats cleaning up huge puddles. Alright, he's had his filter soaking in the tank. Now he's bailing out the tank so that he can get ready to start washing filters in there. See, he's just pouring his wastewater right down the grease trap. Right now we're installing a grease sack around the base of this fan. Even though it's got a grease box, most of the oil leaks out of the base around the cracks and doesn't run in the box. So this customer being right here on a beach, they want their roof to be looking clean. They don't want to see grease running off the roof and down the side of the building. So we put this sack on for them, and it does a pretty good job of controlling the grease and oil before it hits the roof and the ground. When working in a facility like this, wastewater management is critical. You don't want someone standing on their balcony up here watching the operation, calling the authorities and telling you better get down here, you got a crew making a mess out here, polluting the area. So this is how you control it. Now even with his operation, he's got some water here on the ground. But what we're going to do is we're just going to, when we're all done, we'll just power wash that little puddle right down the manhole. Now out here, well, I'll show you in a second. He's setting up over there with the shop vac to vacuum up the little nest he's got in the parking lot there. Fan washing operation. And if no one's ever seen the inside of a grease trap, that's the grease trap. And does it stink? Alright, there goes the wastewater down the grease trap. That's everything that came off the roof. Now there's another pail about almost that size in the kitchen right now that they're going to be pouring down the sinks in the kitchen, which will come underneath them, the building and through them pipes I showed earlier. Alright, he's going to suck up all the standing water that's here in the lot, and all the water will be poured down that grease trap as well. It'll only take about 5 minutes and he'll have it all sucked up. Alright, this is where the wastewater is going, and it'll be going right down that pipe under the building and into the grease trap. Now these guys have a sump pump that they have on their truck that they actually drop in this barrel so that they can just pump it over here. I asked him why he didn't hook it up. He just didn't want to bother. He's just as easy to do this, he said. But on bigger jobs where we have a lot of water, we'll take and put a sump pump down in that drum and just pump it to the floor drain. Disposing of the last of the wastewater, all they have to do now is pull down this drape that's up here, and they'll wipe out the hood and shine it and spiff up the place, and they'll be out of here. This job took, they started at noon. It's 2:15 right now. They'll be out of here in another 15-20 minutes. So 2.5 hours for this type of job is probably about right. All right, we're out of here. That's it for wastewater disposal.